Okay, let's look at problem 23 here. It gives you this little sum 1 minus 1/9 plus 1/2 minus 1/25, etc. It gives you a piecewise defined function. Really, you could probably disregard this for the most part. It's just saying that if n is odd, they're using this rule, which is a geometric type rule. And if n is even, they're using this rule, which looks like a p-series or something that could be compared to a p-series type thing. They want to know which of the statements is true about it converging and diverging. And I can see why people have questions about this one. The first thing I would do is figure out, if you can, does it converge or diverge? And we're going to find out that it converges, which is going to help us eliminate option 2 there, which says that it diverges. So what they're trying to point out with that little piecewise defined function is simply this. This sum could be broken up by its odd numbered terms. So it's equal to 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 and so on. And then the even number terms, they're all negative. I'm going to go ahead and factor the negative out. So they're equal to 1/9 or 1 over 3 squared, 1 over 25, 1 over 5 squared, 1 over 49, etc. Okay, so this right here is geometric. Its common ratio is 1/2, so it converges. So it adds up to something finite. And then this sum right here, I wouldn't say it's a p-series because it's missing the 4 squared and the 6 squared and all that fun stuff that you'd need for it to be a p-series. But it's a smaller piece of a p-series. So basically, even if you had the missing 1 over 1 squared, 1 over 4 squared, 1 over 6 squared, all the missing numbers that you could add to make this a p-series, it would have been a convergent p-series. And so this is a subset of a convergent p-series. So I'm just going to go ahead and say convergent p-series, even though it technically isn't. But that is the thinking that I'm using. So here's the deal. This adds up to something finite. This adds up to something finite. You're basically subtracting 2 finite numbers, so you're going to get a finite answer. So for that reasoning, I would say that this sum, as given, converges. So I'm just going to cross out option 2 there that says that it diverges. Now, as far as the rest of the mumbo jumbo, so the sum converges because the terms of S alternate and the value of the terms go to 0. So that is not the reason that I just said that it converges. As a matter of fact, what they're really trying to do here in kind of a convoluted way is trying to test your knowledge of the alternating series test for convergence. I do recommend you review that for yourself because while they have kind of knocked off quite a few of the convergence and divergence things that they're going to test you over, alternating series test is still on the list, on the short list. So review that test for yourself. But the alternating series test, you'd need to have that the non-alternating part, the limit, does go to 0. But you'd also have to have that the value of the non-alternating part was decreasing in value. And if all of this reasoning is about this sum at large, just as written. And you can see that the absolute value of the terms does not decrease in value. So it goes down, then up, then down, then up, down, up. And so you wouldn't be able to use the alternating series test on this sum as is. So does this sum converge because the terms alternate and the value of the terms goes to 0. No, that's not why. Plus, that's, you know, partial, a partial truth of a bigger test. Does the value of the sum converge? Although it's not true that, and what they're saying here is the magnitude of the terms decreases in value. So the sum, did it converge even though it's not true that the magnitude of the terms decreased in value for all n? And yes, that is true. So I would say option D here, just 3 only. Hope this helps you guys.